Assalamualaikum warahmatullahi wabarakatuh. We are from group 4 and today we are going to present on how to use SPSS system in 4 components. In the data cleaning and coding phase, we reviewed the dataset to ensure it was ready for analysis. Since all 267 responses were complete and valid, no cases needed to be removed. We then confirmed the coding of categorical variables like gender and Likert scale items, ensuring all were numerically consistent. We also added descriptive labels for each variable to make the SPSS output easier to interpret. Lastly, we checked that all variables were correctly set as nominal, ordinal, or scale depending on their type. This step helped us prepare a clean, organized dataset for further statistical analysis.
The next one is descriptive statistic, which is they have a number of users. So descriptive analysis is used in study that involve human participant because it's useful to collect information on the number of people or cases in the sample. Descriptive statistics include the mean, standard deviation, range of scores, skewness, and kurtosis. Then this statistic can be obtained a number of different ways, providing a variety of information. So descriptive statistic is divided to two variables, which is categorical variable and continuous variable. And the first I will show to you is the categorical variable. To obtain descriptive statistic for categorical variable, you should use frequency. This will tell you about how many people give each response, like how many males or how many females. Categorical variable is like age, gender, or job, and it doesn't make sense to asking for means or standard deviation. Okay, first you go to the menu and click analysis. After that, you click on descriptive statistic and frequency. So at this point, you can choose and highlight the categorical variable you are interested in. So at this point, I choose gender as my variable that I interested and move the variable into the variable box. After you move the variable into the variable box, you click OK. Now you can see the statistic of the gender itself, which is we have 267 respondents and most of them is female, which is 200%, and the others are males. So it shows that the female respondents are more than male respondents in the studies. So for the next one is a continuous variable. For continuous variables, it's easier to use descriptive, which is will provide you the summary statistics such as mean, median, and standard deviation. Okay, before you go to the continuous variable in the SSPS, you need to collect this descriptive information on your continuous variable in one go. So first, click transform and compute variable. Then you need to choose one of your variable that you want to compile. Okay, so the variable that I choose is social. First, you need to click open bracket and you need to find the social variable. Okay, then you click social 1 plus social 2, okay, plus social 3 plus social 4, and divide them into 4 because they have 4 variables. Don't forget to type your target variable. So I type social. After that, click OK. Minimize the window and you can see at the end of the column the variable that we have combined before. Now we can continue. So first, click analysis, descriptive statistic, and then click descriptive. After that, you can click all the continuous variable that you wish to obtain descriptive statistic and click the arrow button to move them to the variable box. Then click on the option buttons, make sure mean, standard deviation, minimum, maximum are ticked, and click on the skewness and kurtosis too. After that, you can click continue and then you click OK. Now you can see on the screen is the descriptive statistic. They have minimum, maximum, mean, standard deviation, skewness, and also kurtosis. From here, you can see the case study have a consistent response or not because you can see from the standard deviation. If it's score below 1, then they have a consistent response. Other than that, the skewness value provide an indication of the symmetry of the distribution, while kurtosis, on the other hand, provide information about the thickness of the distribution. So, if you the distribution is perfectly normal, you will obtain a skewness and kurtosis value of 0, but it's almost impossible to get 0. Now, how we want to know they have a normal distribution or not? By converting skewness and kurtosis into the z-score. Calculation of a z-score is dividing the value of skew by the standard error of the skew and dividing the kurtosis by the standard error of the kurtosis. So the last one is SST normality, which is used to describe a symmetrical or bell-shaped curve that have a greatest frequency of score, and also can be assessed to some extent by obtaining skewness and kurtosis value. So first, go to menu and click analysis, find the descriptive statistic, and then click explore. Now you can see the dependent list, factor list, and label case by. Make sure in the display section you need to select both. Okay, now click on the variable you are interested in. Click on the arrow button to move them into the dependent list box. After that, you click the plot buttons. Then you click the histogram, and you must unclick the stem and leaf. Then you click the normality plots with test, and then you click continue. After that, you click on the option buttons, click exclude cases pairwise, and then after that you click continue. Then you click OK. Now on the screen it show you the histogram for the variable that we choose, which is aesthetic variable. You can see here the shape of the histogram, and then you can see the unbalance of the graph itself. On this graph, you can see the outliers respondent for this variable. So if you want to make the graph more linear or more beautiful, you need to clear out the outliers respondent. I will show you the test of normality. They have two tests of normality, which is Kolmogorov semi-groove and Shapiro-Wilk test. For this test, you need to see the significant column, and you need to make sure that the number is much below than 0.05. If not, then the assumption of normality has been rejected.
Okay, now let's move on to reliability testing or validity testing. This page is intended to help us determine whether the data we collected is reliable, or in other words, trustworthy and robust. First, in the SPSS menu, click the Analyze button, then search for Scale. Click Reliability Analysis. A box will appear listing all the variables or data points you have recorded. For example, suppose I select one hypothesis topic called layout. Under layout, we have 10 items. Click each layout item and then click the arrow to move them into the items box on the right. So, we include all 10 layout items in the analysis. Next, ensure the model is set to alpha, Chromebats alpha. In the scale label field, enter the label you use in your dataset. For instance, if your PDF refers to it as Destination Social Media Foodscape, enter that in scale label. Before pressing OK, we need to set the statistic options. The first one, click statistic at the top under descriptive for tick all, which is item, scale, and scale if item deleted. For inter item, select correlations. And finally, click continue and then click OK to run the reliability analysis. After clicking OK, the output window appears displaying the full results of our reliability test. From here, we can see sections for case processing summary, reliability statistics, a detailed table showing each question and item. The first, interpreting the output, reliability statistic. For example, Chromebase alpha is 0.836. That means it's high, indicating that the skill is reliable and the data is trustworthy. And the second one is case processing summary at the above. It shows valid, which is 267, meaning 267 respondents answered the questionnaire and 100% participation among your data set. And the next one, we can see in the item total statistics session, it shows what the alpha would be if each item were deleted one at a time. For instance, if you remove question 1, which is the social media sites of Melaka are difficult to navigate, the alpha becomes pointer 8.841. If you remove question 4, the social media food sites of Melaka are user-friendly, the alpha becomes pointer 812. This table helps you see if removing any item improves reliability. So, that covers the full process of interpreting SPSS reliability output. Next, you can see here the data from all of the questions from the questionnaire. As you can see here, for the social section, they have 4 questions. So, we have to combine these 4 questions for one variable, which is social factors. For combine these 4 questions to one variable, which is social factors, first on the top of the menu, click transform, then click compute variable. At target variable, put one variable that all the questions we want to combine. So as I do here, social total, and as a reminder, please don't put a space here. Then click type and label and put full sentence. At numerics expression box, click around bracket button and then choose social 1. Click plus button and continue to choose social question. Then click division sign and put number 4 because these have 4 questions. And then click OK. After that, you can see the complete out. And on the last section here, it appears combined mark of social factor questions at social total section. Here, you can see 5.0 mark, and if you compare it to the first respondent at social section, also have 5.0 mark, same as social total. Next, we move to the multiple regression, and this is the procedure for multiple regression. At the menu, the top of the screen, click on Analyze, and then select Regression and Linear. Click on your continuous dependent variable. As you can see here, I click Travel Intention and move it into the dependent box. Then click on your independent variable. As I choose here, social factor 1, and click on the arrow to move them into the independent box. Okay, for method, make sure select enter. Then click on the statistic button. Select the following: estimates, confidence intervals, model fit, descriptives, part and partial correlations, and collinearity diagnostics. At the residual section, select case-wise diagnostics and outliers outside 3 standard deviations, and then click on continue. Next, click on the options button. In the missing value section, select exclude cases pairwise and then continue. Click on the plots button and then click on ZRESID and the arrow button to move it to the Y box. Then click on ZPRED and the arrow button below to move it into the X box. In the section headed Standardized Residual Plots, tick the Normal Probability Plot options. And then continue. Click the Save button. In the section labeled Distance, select Mahalanobis box and Cooks. And then click Continue and OK.